Hey guys, today I'm going to be talking about probability. Probability is basically how likely an event is to occur. So, for example, the probability of landing heads when a coin is tossed is how likely it is that it will land heads. So, the experiments we need to know are tossing a coin once has two possible outcomes, heads or tails. So, the sample space denoted by that symbol for tossing a coin would be heads, tails. Tossing a coin twice has four outcomes. The first time it could be heads or tails, the second time it could be heads or tails. So the sample space could be heads, 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 tails, tails, heads, or tails, tails. Tossing a coin three times would have eight outcomes. The first time heads or tails, the second time heads or tails, and the third time heads or tails. So the sample space for that experiment would be all these eight outcomes. Another experiment we need to know is rolling a six-sided dice. Rolling it once could have six outcomes. You could get 1, 2, 3, 4, 5, or 6. Rolling it twice, you would have 36 outcomes of ordered pairs. Like the first time you'd have 1, the second time you'd have 1. So 1, 1, 1, 2, all the way to 1, 6, 2, 1, 2, 2, all the way to 2, 6, and so on. So rolling it n times, you would have 6 to the power of n outcomes. Because through conducting these experiments, we can notice that the total number of possible outcomes, so the number of outcomes in the sample space, is the number of outcomes from doing the experiment once, let's denote it by m, to the power of the number of times the experiment is repeated, let's denote it by n. So for example, since the number of possible outcomes for tossing a coin once is 2, the number of possible outcomes for n coin tosses would be 2 to the power of n. Same thing for rolling a dice. Then the probability axioms, theorems, and laws we need to know are axiom 1 is that the probability of the entire sample space is 1. So the probability of every event in the sample space occurring would be 1. Axiom number 2, if A intersection B, so if A and B have no intersection, like they cannot happen at the same time, it's impossible for them to happen at the same time, they're mutually exclusive. So then the probability of A union B would be the probability of A plus the probability of B. If A doesn't equal to phi, so it exists, then probability of A is not equal to 0 because it could happen if it exists. Then theorem 1 is probability of an impossible event is 0. So if it's an impossible event, it can never happen. So it would be 0. Probability of the union of ai from 1 to n is equal to sigma the probability of I equals 1 to n of probability of ai if they're pairwise disjoint. Pairwise disjoint means, for example, let's say we have 4 items in a set. The intersection of A with B is equal to 0. The intersection of B with C is equal to 0. The intersection of C with D would be equal to 0. That's what pairwise disjoint means. So that means the probability of A1 union A2 union A3 would be the probability of A1 plus the probability of A2 plus the probability of A3. Then theorem 3 is that the probability of A is the number of outcomes of A over the total number of outcomes in the sample space. So probability, for example, of getting heads when a coin is tossed. In the sample space, we already saw for one coin toss that heads appears once and the number of outcomes is 2. So heads is 1 and the total is 2. So the answer would be 1 over 2. The other rules we need to know is that probability of A plus probability of A complement, which means everything except A, is equal to 1. If A is a subset of B, then the probability of A would be less than or equal to B. So A is a subset of B, that would mean that everything in A is inside B as well. So the probability of A is smaller than the probability of B. Then the probability of A union B, if it's not mutually exclusive, would be probability of A plus probability of B minus probability of A union B. A union B complement would be A complement intersection B complement, and A intersection B all complement would be A complement union B complement. That's all we need to know about probability, so thank you for watching. Please subscribe to see more videos for statistics and any other subjects you need to study for the finals. Bye!